Hi everyone, good morning. Can you see my screen everyone? Online, online guys, can you confirm anyone? Am I audible? So confirm చేయండి.
Yes, sir. Your voice is audible.
Fine. Yeah, so we have completed 4 sessions so far, right? DevOps introduction and also cloud introduction and also question and answers and also SDLC, software development lifecycle, right? So today is fifth session, which is servers networks basics, right? So before going to cloud, first we need to understand what is server, what is network, what is load balancer, what is IP address, what is subnet mask, what is gateway, what is yeah firewall, failover. These are all very important clusters, right? So before going to cloud, we need to understand all these things, right? So anyone newly joined today, can you share your WhatsApp number and email address in the chat so that I'll provide you previous recordings. My mobile number is 96422 Everyone can take down this number, right? You can share your WhatsApp number, email address in the chat so that we'll provide you previous recordings. Fine. Yeah. Let's get started. So introduction to servers and networks, right? So before going to cloud, first we need to understand this servers and networks. Still people are joining. Fine. Today's agenda is what is server, types of servers, server client model, best practices, server architecture, what is operating system, types of operating systems, what is the network, types of networks, what is IP address, what is subnet mask, what is gateway, what is router, firewall, failover, load balancer. So up to here we can cover today. Up to here we can cover today. So this will take 1 hour, right? So before going to cloud server infrastructure, okay. First of all, we need to understand the basics. These are the very basic concepts here, and also the terminology is very important. Terminology is very important, right? Yeah. So while working on cloud infrastructure, the terminology, so which is very important. That is why we need to understand the basics here. Okay. Yeah. Let's go with the one by one. Yeah. So what is server? What is server, anyone? In real-time projects, we use the servers. Developers always connect the servers. They develop the code on servers, right? So basically, what is server? Server is a computer. Server is having high computing power, right? So number of CPUs, number of memory modules, number of storages, right? Yeah, this server we can configure in central location, which is data center, right? So we can connect these servers through network, either local area network or wide area network or Wi-Fi or any networks, right? Yeah, see here, this is the definition. So a server is a computer that serves information to other computers called clients, right? Yeah, can connect to a server through either local area network or wide area network such as the internet, right? So normally every developer, every tester, every DevOps engineer, they work on servers only in real-time projects, right? So laptops, desktops we use for only to connect servers, right? Yeah. So in laptop, we can log in as a user and we can connect our servers through network to share the resources, to copy the resources, to work on the resources, right? Now, types of servers. We have 3 types of servers are available. So blade server, rack server, towers server. What are those? Let's go with one by one. Blade server. So a blade server is a modular server that allows multiple servers to be hosted in a smaller area. So this is the container. This is the container. Instead of this container, we can insert small thin servers, which are we can call it as blade servers, right? So one container will have 16 capacity, 16 port capacity, 16 servers you can insert, right? 32 servers can, 48 servers can, like that. So based on the requirement, right? So Blade server is a modular server that allows multiple servers to be hosted in a smaller area. So these servers are physically thin, typically only have CPU, memory, integrated network controllers. These servers are having only CPU, memory, modules, and integrated network controllers. Without storage, how these servers can work? So only CPU, memory, integrated network controllers. No storage. How the servers will work? So backend will connect external storages, right? Yeah. So some Blade servers. Normally, we use the external storage to external storage we can create and attach to the servers, right? So Blade servers are often seen in large data centers. So like enterprise level, these are very faster. These thin servers are very faster. So these servers we can use in large data centers like Google, UHG, yeah, AT&T, Verizon, right? And Twitter, Facebook, these data centers. We use the Blade servers. Okay. Second one is rack servers. So these are the traditional servers. Rack servers are traditional servers. So rack server is a server mounted inside of your rack. Rack servers are typically general purpose servers that support broad range of applications and computing. So most of the data centers they are using the rack servers only. So rack is it is a container, big container. In that we can insert server, we can connect power network, and we can install operating system, and we can install patches, plugins, everything, and we can hand over to project, right? Yeah. Next one, towered server. A tower server is a computer that is built in an upright cabinet that stands alone and that is designed to function as a server. So this is bit water server currently, right? So these physical servers will be maintained by who will maintain this? So currently AWS is maintained, right? So earlier, when we use our local server room, local data center, we used to handle that. So currently, we are using cloud infrastructure, cloud servers. So AWS team managing the servers, right? So as a DevOps engineer, as a cloud engineer, what we are doing, we are accessing virtually, right? We are getting resources now. So client server model, right? So this is a server. So through network we can connect our servers. These are the desktops, right? Normally in real-time projects we are using desktops. We get laptop. Along with that we get one desktop. Yeah. So we can connect our servers through network. When we send request, server will give response. Okay. So when we send request, server will give response. Yeah. So this is another type of server client server model, right? So through desktop or we can use laptop or desktop or even we can use tab also to connect our servers through internet, right? Yeah. Now, so let us go and discuss about server architecture, right? Server architecture. So what is server architecture? Server architecture is the foundation layout or model of a server. So based on which a server is created and are deployed, right? It defines how server is designed. Now, we'll discuss about few examples here. Yeah, fine. So server architecture, first phase of implementation. So in 90s and early 2000, how the server architecture? In 1990s and early 2000, how the server architecture? Let's try to understand. Yeah, so this is the first phase of implementation, which is a initial initial phase of implementation, right? So initial phase of implementation, this is first phase. First phase. So in 1990s and early 2000, how the project teams, how they used to configure the servers, how they designed servers. Okay, let's try to understand. For example, so we have different applications are there like Java, Python, right? Tomcat, and also yeah, we can say one more application which is JBoss. Yeah. So in 1990s and early 2000, so this, yeah, project teams, they used to take for each application one server in 1990s and early 2000. So by the time hardware costing is very higher, too much cost, right? So by the time, so even desktops also too much costing, 1990s and early 2000. So every project team, they used to take for each application they used to take one server, right? So we have four applications: Java, Python, Tomcat, JBoss. Yeah, project team, any project team, they used to take four servers for four applications like this, right? So these are the yeah. By the time, highest capacity of the storage 1 GB, highest capacity of the storage. So these are the 1 GB capacity storages, 1 GB storage. Okay. So like this. So 1 GB storage is highest capacity. So four applications, four servers, right? Yeah. So for example, they deployed here Java. Java occupied, for example, 300 MB. Okay. So remaining space will be wasted, right? Remaining 700 MB space will be wasted here. Okay. 700 MB. Yeah. So Python occupied, for example, 350 MB. Remaining 650 MB will be wasted here, right? So next one, Tom, Tomcat occupied 400 MB, for example. So remaining space will be wasted. Right? Next one, JBoss. So JBoss occupied 450 MB. So remaining four space will be wasted here. So yeah, each application, so one server the project teams used to take in 1990s and early 2000. Okay. So 550 MB will be wasted here. Fine. So by the time hardware costing, server costing is too much costing. So clients, yeah, project teams, they used to spend more budget for the hardware, right? So here, what will happen? What happened here? So the utilization is less, but costing is more. The server utilization is very less, costing very higher. That is why. So this is completely second phase of implementation. In second phase of implementation, project teams used to configure one single server, high capacity server like this. They used to deploy all the packages on a single server. Okay. So here, Java, Python, Tomcat, and also JBoss. JBoss is application server. JBoss. Okay. Yeah. So these are the four different applications. They configured on a single server all the applications. So here, so Java developers, they access Java server, Java application, right? They can log into the same server. They access the Java application. Python developers, they access the Python application. So Tomcat application, right? Respective engineers, they can access Tomcat. JBoss, respective engineers, they can access JBoss. So all the team members, they can access the same server. They can access their respective applications, right? Here, what will happen? Yeah. So four people are accessing their respective applications, right? So Java user may access Python application also. There may be chances to access. Python user may access Tomcat application also. There may be chances to access. Tomcat user may access JBoss also. There may be chances. because 4 people are logging into the same server. For example, so four people are staying in a 2 BHK flat. 4 friends, they are staying in a single one flat. So 2 bedroom flat. So 2 people are staying in one bedroom, 2 people are staying in other bedroom. The 4 people commonly access kitchen and dining, right? Because they are using the same flat, right? The same way, so Java user may access Python application. There may be chances security layers will be there, security will be there. There may be chances, right? And Python user may access Tomcat user may access JBoss user may access other applications, right? So there may be chances. That is one of the security concern. And also, in case this server is crash, what will happen? All the applications will be gone. This is also one of the drawback. That is why this is also failed concept. This is also failed concept, right? Yeah, slowly, in third phase of implementation, what happened? Virtual servers came into the market. Third phase of implementation. In third phase of implementation, yeah. So virtual servers came into the market, right? Virtual servers, virtualization. So what is virtual? What is virtual server? Virtual server is a server which is not a physical server, right? Yeah, it is a imaginary server. Fine. So in third phase of implementation, project teams used to take one high capacity server like this. This we can say base OS, base operating system. Okay. Yeah. So this can be physical server. This can be physical server. Physical server. Right. So on top of this, we deploy one layer, software layer, which is VMware or hypervisor, or Citrix. This is the software. This is the layer. So on top of the physical server, we can deploy this. This will allow you to create the virtual servers. Yeah. On top of this layer, we can create virtual servers. So these are the virtual server. So as per the physical server capacity, we can create virtual servers, right? So these are the virtual servers, different servers. So these are the different flavors we can install here, like Windows 2022 base OS, right? And here we can deploy Ubuntu Linux. Here you can deploy CentOS Linux. Here we can deploy RHCL, Red Hat Enterprise Linux. Here we can deploy SUSE Linux. Like this, whatever flavors you want to deploy, you can deploy as per the project team requirement, right? So these are all servers. These are all servers. These are all, we can say, virtual servers, right? So this virtual servers utilize the RAM, CPU, storage from physical server only, right? Yeah. So here, so this is this server is having RAM, high capacity RAM, which is 48 GB RAM, 48 GB RAM. The CPU, 32 core, and the storage 10 TB, like this, high capacity server. So these servers can utilize hardware resource from physical server. So this layer will allow to create the virtual servers. So currently we are using virtual servers in real-time projects. Okay, yeah. So here also we have some drawbacks in virtual servers also. So many drawbacks are available, right? So when we want to deploy operating system like Windows or Ubuntu or CentOS or Linux or whatever, so we use ISO emails. ISO emails. What is ISO emails? It is a master copy. To deploy the operating system, we use image. In our laptop, when you want to install Windows, we require image, right? For example, normally we sometimes what we will do, if any virus attack, any files corrupted, what we will do, we format our operating system, we reinstall. We go to hardware center, they perform that. We can also perform. It's very easier, right? So we use the image. That image we can copy into pen drive. That pen drive we can connect to our laptop, and we can convert that pen drive into bootable drive, right? So by using the pen drive, we can boot the laptop and we can install the operating system, right? So the same way, so we use the ISO image here. Server side, we use the ISO image. ISO full form is International Standardization Organization, right? So this is the master copy. By using this ISO image, we can deploy operating system, right? Yeah. So here, what will happen? When we deploy operating system size minimum would be 6 GB to 18 GB. Operating system size I'm talking about. So here we have 5 into 5, 25 servers are there. So each server is having 6 GB to 18 GB of the storage for only operating system. So on top of this, again we need to deploy applications, right? Patches, like we need to deploy, right? It takes more space. So minimum 6 GB to 18 GB. Why I'm telling this 6 GB to 18 GB? Windows 2022, this flavor utilize 18 GB of the storage for only operating system. CentOS will take 6 GB only. RHL takes 8 GB. Like this, yeah, like that. So different operating systems take different size of the image, right? So on an average, for example, 5 into 525 servers, each server can take 10 GB, for example, 10 GB into 25 servers. How much GB we can utilize for the operating system? 250 GB we need to spend for only operating system. So on top of that, we need to deploy applications, plugins, patches. So this servers utilize more space. That is one of the drawback, right? And also when we restart any server, it takes 4 to 8 minutes. 4 to 8 minutes. When you restart any server, physical server, or cloud server, or virtual server, any server, it takes minimum 4 to 8 minutes. So when you restart your laptop, it takes within 1 minute. It will be restarted because laptop is having only one CPU, one memory, one storage. But servers are having multiple CPUs, multiple storages, multiple integrated controllers, right? RAID controllers. That is why it takes more time to restart. So and also it will update patches every time. When you restart, it will update patches, right? So this is also one of the drawback, right? And also deployment time and downtime is high. So here in in virtual servers, deployment time and downtime. Deployment time. What is deployment time? Anyone? Deployment. What is deployment? Installation, right? So for example, code installation, application installation, that take more time in cloud servers, in virtual servers, or physical servers, right? Yeah. So when you want to what is downtime? Anyone? Downtime. Yeah, online everyone following, right? So what is downtime? Which is maintenance time. Downtime is maintenance time, right? So normally every month we install patches, updates in servers. We install latest updates. So in our mobile, Android mobile, Apple mobile, we get updates, right? So every month we install, right? So the same way, server side also we install the updates. Once we install updates, make sure the server should be restarted, right? That is downtime. If you want to restart server, we require downtime. For example, in the server, so Flipkart is running, for example. So we need to get approval from the client. Without approval, you should not restart the server. stop the server or restart the server, what will happen? Application will be down, right? So before restarting server, we need to enable other server and to restart server. Otherwise, what will happen? Application will be down. So client business will be impacted. Escalations will be downtime is very important here. Okay. So here in virtual servers, deployment time is high and downtime also high. These are all drawbacks. Still, we are using virtual servers in projects, but these are the drawbacks, right? So that is why in fourth phase of implementation, we are using advanced infrastructure, which is very, very important. So currently, we are using very advanced infrastructure, which is a fourth phase of implementation. Which is Docker containers. Docker containers. We are using Docker, right? So in Docker, we are using containers, right? Yeah. Now let's try to understand Docker containers, Docker infrastructure. So you can say Docker infrastructure or Docker containers. Now, same as virtual servers, we can take one server which can be cloud server, which is AWS server. So EC2 instance. So this terminology is very important. In AWS, you can call it as EC2 instance, server name, server, you can call it as EC2 instance, right? Yeah. So we take one AWS instance, AWS server, right? On top of this, we deploy one layer, which is Docker image, Docker image. Okay. So on top of that, we run the Docker containers, Docker containers. Okay. So these are the Docker containers. Right? Yeah. So in this containers, we can deploy different packages, different operating environments, like same as virtual servers. Here we can deploy Ubuntu, CentOS, RHCL, and here we can deploy Windows, right? So whatever flavors we require. So, but what is the difference here? So these are the virtual servers, these are the containers. What is the difference here? Okay. Yeah. So when you want to deploy operating system on a container, yeah, we use the when we run a container, only lib and bin files will be installed. Lib and bin files. Okay. So here to deploy, we use the Docker image here, not ISO image, Docker image. Okay, Docker image. So this image will take 200 MB only. For operating environment, it takes 200 MB only. So here we are using 6 GB to 18 GB, but here we are using 200 MB only. Why this much of drastic change? Because of so whatever files required for the applications deployments, so those are bin and lib files. Lib Lib means library. Bin means binary. Binary library files. So to deploy the applications, whatever application developed by developers, so if you want to deploy that, so these files are enough to you. Not required full-blowing operating system. Full-blowing image not required here. Only library binary files required here to deploy the applications, right? Yeah. So here in containers also same functionality, no changes, right? So whatever we are performing on the virtual servers, same activities you can perform in containers also. But here, so very less size they are utilizing, containers are utilizing. And also when you restart container, right? So very quickly, very faster, the containers will be restarted. So for example, any developer is working on the container. So yeah, they will not understand whether it is rebooted or not, restarted or not, because very faster, right? Yeah. So these containers are lightweight, standalone. We can move anywhere, we can use anywhere. We can deploy any operating systems, right? So currently we are using digital applications like Flipkart, Amazon shopping site, Mintra, Meesho, right? Different websites we are using, right? Online shoppings. So when we book any product, that will be processed immediately. Why that much of faster? Earlier, 6 years back, 5 years back, when we book any product, so they used to take 10 days, 15 days like that to deliver. But when we book any product here, so currently, so they are delivering within hours also. So I booked one mobile recently, latest mobile, which is a latest mobile for my yeah family member. I booked the mobile. They delivered within 4 hours, right? Yeah, latest Apple mobile booked recently. Within 4 hours they delivered. So they pick from the local warehouse. They delivered. So when we place the order, that will be processed immediately, right? Even so, when we book groceries like Blinkit, Jepto, Dunjo, different websites are there, right? Different applications. So when we book any groceries, within 5 minutes, within 7 minutes, they are delivering, because backend they have very high-end containers are using their backend. So backend they are using Docker infrastructure, Docker containers, Kubernetes infrastructure. That is why when we place any order, immediately that will be processed. Okay. So even any online products, right? Within hours also they're delivering. So some products they're delivering within few days, like 3 days, 4 days, like that. But so most of the applications they're delivering as soon as possible, like 4 hours, 6 hours, one day, within one day, right? Yeah, because of backend they're using so very high-end infrastructure like Docker, Kubernetes. Fine. Yeah. So here, so this is the full-blown operating system. This is the yeah, this is the full blowing operating system. This is the lightweight. So both are same functionality, right? So to deploy client applications, we don't require full blowing operating system here. Whatever files required, that is enough to you, like bin files, lib files, binary library files to deploy the applications, right? Yeah. So this is a lightweight, this is a heavy, right? This is a bit costlier. Licensing also a bit costly. Is very less. So yeah, licensing cost is very less. So cost effective. Docker licensing is cost effective, right? So client always look for the cost saving, and also it is very fast, right? Time will be saved. When you deploy an application, deployment time and downtime is less. Deployment time and downtime is less in Docker containers. So client always look for the cost saving, right? So licensing cost is less and downtime not required here, and deployment time also very less. When you deploy applications very quickly, that application will be deployed, right? These are all advantages of Docker infrastructure. That is why every project team they're migrating to Docker infrastructure currently. They're migrating their applications to Docker because very faster and also less costing. For example, 4 people, yeah, so 4 or 3 people, for a small family, one small family, they want to live normal living. What they require? What they require? Food, clothes, right? Yeah, shelter required, normal shelter. Okay, so if they want to live lavish, they require furnishing, AC, right? So this is lavish. Virtualization is lavish. This is normal living. Both are same functional, right? Yeah. So this containers we can move anywhere, we can use anywhere. These are lightweight, standalone, right? So we can use anywhere. Yeah, I give you a small example. So one of my ex-colleague, okay, yeah. So we joined in Verizon Data Services. We worked with Verizon Data Services. In 2005, we joined as a fresher in Verizon Data Services. Verizon Data Services is one of the MNC company. It's a product-based company. It's a very big company. In 2005, November 28th, we joined in Verizon Data Services as a fresher. Right? 7.5 years we worked together. So he's a developer actually. He's .NET developer. I'm a admin, virtualization, VMware, storage admin. Right? So I moved to Capgemini. He moved to Wipro after 7.5 years. Right? Yeah. So currently he's working with another company, one MNC company, big company. He's in Hyderabad. He's having own house. He's having own furnishing, everything. Right? Recently, not recently, 2 years back, he moved to Manali from Hyderabad to Manali. Complete he moved husbands and kid. They moved to Manali. He's working from home, completely working from home. So he's working from there, Manali. So because that atmosphere, everything, that environment, right, is good currently, right? So compare Hyderabad, so there it is no pollution, nothing, right? So yeah, he moved to Manali completely. Yeah, from Manali he can move anywhere, he can stay anywhere. So he's having limited resources, limited furnishing, limited things, right? He can move anywhere, he can stay anywhere. But if you settle here, we cannot move immediately, right? So if you have, if you settle here, we cannot move immediately. So that is lightweight. We are we settled here. That is heavy. That's the difference here, right? So virtualization and Docker, VMware, virtualization servers and Docker servers. Docker not servers, containers. Should not call it as server, right? It is lightweight. Yeah. So currently Docker is very popular now. Docker is very popular now because licensing cost is very less, very faster, right? So before Docker also we used to use containers. Before Docker also we used to use containers. Before Docker, what happened? Yeah, we used to use containers like LXC, LXC, Jones, LMCI, F5. LMCI full form is let me container for you. LXC is a Linux container. Yeah, Jones, Solaris container. LMCI. So this is Google container, right? Yeah. So before Docker, we used to use these containers. Before Docker. So these are the platform dependent containers. These are the platform dependent containers. What is platform dependent? Anyone? These are the platform dependent containers. Real time guys, what is platform dependent? These are the platform dependent. Yeah. So platform dependent containers. These containers work on their respective platform only. LXC run on only Linux. Jones run on only Solaris. LMCIFI run on only Google. Right? So these are the platform dependent. These containers are failed to platforms only they can run. Right? But currently we are using Docker. Right? So Docker containers, irrespective of operating system. Why Docker is very popular now? Right? Docker is very popular now, famous now. Right? So irrespective of operating systems, if irrespective of operating system, we can run this containers on Linux, Solaris, Windows, and even Mac OS also. Mac OS also. So any operating system, we can run this Docker containers, right? So these are the platform independent. These containers are platform independent containers. These are the platform independent, right? So currently Docker is very popular now because of platform independent. So we can run this containers on any any platform, any operating system, right? Linux, Solaris, Windows, and Mac OS also, right? So that is why currently every project team, they are opting their, yeah, they are migrating their applications to Docker containers. They're, yeah, they're configuring Docker infrastructure in their projects, right? So Docker is very popular now. So if you are good in Docker, you can easily crack your entry. So Docker, Kubernetes, both are very important. Docker, Kubernetes, okay? So these tools will go very deep dive. These tools, yeah, these two tools are very, very important. So currently, most of the project teams, they are using this. Most of the project teams, Docker, Kubernetes. So if you are good in this two tools along with this AWS cloud platform, you can easily crack your interview, right? Yeah. So whatever activities you perform in real-time projects, same activities you can perform in Docker and Kubernetes. So interview tips and tricks. How can we crack the interview? Interview preparation, and also Docker roles, responsibilities, Docker challenges, Kubernetes challenges. Everything will be covered in our course. Okay. Yeah. Clear it up to here? Any questions, anyone? Online guys? Any questions, anyone up to here? Classroom guys, you can questions unte adagandi. You can ask now. So currently we are using fourth phase of implementation. So that is why we are using digital applications like Flipkart, Amazon shopping site, Mintra, Meesho, Trends, online, right? Yeah, these are all digital applications. So digital applications run on Docker infrastructure only, not on physical, not on virtual, right? So currently, yeah, online shopping is very popular now because of Docker and Kubernetes. Fine, clear it, everyone? Yeah. So while working on Docker, how to configure Docker, how can we install Docker, how can we work on Docker, we'll see that practically. So this is just introduction. Okay. Yeah. Now let us go back to server architecture. See here, this is the server architecture. So while working on AWS cloud, I'll show you this architecture. Okay. Next one, what is the operating system? Yeah. So normally in our laptop we are using Windows, right? Windows 11 or Windows 10 we are using, right? So which is the operating system? What is the operating system? It is the right. It is the interface between user and the computer hardware. So computer hardware always understand binary language. Binaries. What is binary language? Zeros and ones. Zero 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 one one zero zero one one one, like that. So computer hardware like server hardware or laptop hardware or desktop hardware understand only binary language, but a human will not understand that. That is why we require one translator, which is operating system. This will translate from binary language to human readable language and vice versa for effective communication. See here, this is the definition. So operating system is an interface between the user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. Right? See here. So operating system is in middle between hardware and end user. Right? Next one. Types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform only one task at a time. So for example, this is MS-DOS. So this is a very old operating system. In MS-DOS, only one user can log into the system. He can perform only one task at a time, right? Yeah. Second one, single user multitasking operating system. In this type of operating system, only one user can log into the system. He can perform multiple tasks at a time, which is Windows, right? While browsing internet, we can run background audios. While working on some activities, we can run background audios, right? One user can perform multiple tasks. Next one is multi-user multitasking operating system. In this type of operating system, multiple users, which is Linux and Unix, right? Yeah. So Linux, most of the project teams they are using Linux operating system for server side in data centers. So desktop, laptop, we are using Windows only, but server side we are using Linux. Why we are using server side Linux? Because Linux is more secure compared to Windows, right? Linux is very faster, right? So no viruses, no threats for the Linux, right? That is why most of the data centers we are using Linux. So in our course, Linux also will be covered. So how much Linux required, that will be covered, right? Linux commands required nearly 50 commands. Those are enough to you. And Linux architecture, folder structure, Linux user management, Linux file system hierarchy, these all will be covered. Okay. So clear, right, everyone? So this networking part we'll see tomorrow. This will take 1 hour, networking, right? So different types of networks, LAN, WAN, MAN, different types of networks are there. And also IP addresses, gateways, routers, right? Different concepts are there, load balancers, clusters, failovers, that we will see tomorrow. Fine. So day after tomorrow, we are going to start AWS. Okay. So tomorrow we are going to work on networking basics. So once we complete the networking basics, then we'll jump into AWS. So networking basics also very, very important, right? Interview questions also, subnets, gateways, clusters, interview questions are there here. Okay, don't miss the session tomorrow. So day after tomorrow, we'll jump into AWS. So how to create AWS account? How can we connect AWS console? How can we walk through the services? What are the services available? What are the regions? What are the zones? What are the edge locations? These are all we'll discuss on day after tomorrow. So after that, we'll start one by one all the services, EC2, storage, networking, right? Monitoring tools. We'll go one by one. Fine. So the people who are not registered so far, you can register today itself. Okay. So tomorrow onwards, yeah. So some restrictions. Okay. Classroom guys, online guys, you can register today itself and you can add into WhatsApp group. Okay. Yeah. So already WhatsApp group created. People are added into WhatsApp group. So if you are interested, you can add into WhatsApp group. This is fifth session, right? Yeah. So 5 sessions allowed, right? Yeah. Tomorrow onwards, definitely. So restrictions will be there. If you are interested, you can add into WhatsApp group as soon as possible. Fine. Yeah. So we can wind up here. So anyone newly joined, you can share your WhatsApp number here. So my mobile number already shared with you. You can take down. This is my mobile number. So 96422111711. If you have any more questions, if you want to talk to me, if you need any guidance, yeah, you can call me, WhatsApp me. We'll discuss. Fine. Yeah, we can wind up here. So tomorrow we are going to work on networking. Fine. Thank you all.